So hopefully now this is full screen for you. If not, please someone shout at me because I can't see the chat or anything anymore. Okay. So I will give an introduction to Docker containers in the context of Umbrage, but I'm going to try to keep things quite general and also talk a little bit about Docker more generally, because I realize that some people might not be familiar, while others I'm sure are very familiar, and this will be quite boring. Okay. So the goal for this talk is to introduce Docker containers and how they're used in Umbrage. I'll start by giving an introduction to Docker containers. Then I'll discuss how they're used in Umbrage, how to set them up in particular. So I'll kind of go through all the steps with you and demonstrate that. And then finally, of course, how to run them. I'll close off with an overview of the models and benchmarks library, which Linus has already briefly shown, and discuss what kind of models and benchmarks we currently have available. Okay, so from this morning's session, you have hopefully all taken away what Umbrage is in general. It's an abstract interface between UQ methods and models, and it essentially mimics the mathematical model interface in that it turns your model into a black box, which takes a parameter vector and returns some quantity of interest. So it is essentially a function which maps a vector onto a vector. And the corresponding benchmark library exploits the fact that we now have a very easy access to these models by providing very portable containers which contain various different models and benchmarks that you can then just run. And I'll talk more about that at a later point. So firstly, I guess, why containerize? Why use Docker? So I think the first bit is already the installation. So if you've ever worked with a larger PDE framework, whatever that is, then you've probably spent quite considerable time trying to install it, because these kinds of packages tend to have very complex dependencies. Sometimes the build system doesn't even do everything for you, and you still need to link things in. You need to make sure yourself, potentially even, that you have all the dependencies installed, depending on what library it is. And if you use a Docker container around all of this, then anyone who wants to use your software doesn't have to go through all of that process. They can instead just run a single Docker command, which makes it much more likely, in fact, that someone's going to use your model and reproduce your results or produce new results with whatever you've done. The next point that was already brought up by Demetrius is that they're system independent. So you're no longer restricted to particular operating systems. You can run them essentially the same way on Windows, Linux, and macOS. There may be some minor points where this doesn't quite map as well as it should. But in general, it just means that you're completely independent of that and you no longer have to think about this. And in terms of the Docker containers in your Umbrage, the final point is that it gives you some easy access to HPC resources. So even if you see no other reason to use it, this might be a reason. So we provide scripts to run HPC scale experiments on, and we'll talk a lot more about how that works tomorrow, and also show you how to run these. But essentially, we provide configuration files and a Kubernetes setup, which you can just run out of the box, and which takes care of all the load balancing on a large-scale cluster. So this is all talking about cloud computing. We also have some support for more traditional HPC systems, which you can then also use with your Umbrage. Okay. So in terms of containerization, there's actually quite a few different things out there, quite a few different tools. I think Docker is probably the most ubiquitous so far. It's essentially a very lightweight virtual machine, if you want to think about it like that. and it can tend to contain everything. So it contains your code, the runtime, system tools, system libraries, settings, basically everything. And it can also contain data that you need in order to run your simulation, for example. And the Docker engine as a whole kind of is built up of multiple different things. As an end user, the bits that are important to you are probably the Docker API and the Docker command line interface. And for the most part, what we'll be using are those two kind of entry points into Docker. And then underneath all of that is, of course, all of the stuff that makes that work. But that's not what I'll talk about today in this talk. I did want to very briefly mention Aptainer, which is the other containerization tool that we've tried out so far. And that's because Docker, while it will work on your own systems and also on your own clusters if you have control over those, some HPC systems don't allow you to use Docker, so they don't have Docker installed, and for security reasons don't want to install it. And Aptainer can then be an alternative, and UMBridge works essentially the same way with Aptainer as well. Okay, so if you haven't seen it before, then you can have a look at how to install it. There's a link in these slides, and the slides are published on the workshop webpage as well. There's also documentation which helps you get started, and tutorials that you can have a look at. But essentially, I'll hopefully cover everything that you need now, at least for getting running with UMBridge. Okay, so let's start by trying Docker on a really, really basic example. And for this, I'm just going to switch into my command line. And so now what we can do is we can try to run hello world. And all of that this command is doing is, well, the Docker run is going to say, well, I'm going to run some image called hello world. And if hello world is not installed yet, then it will also go and it will fetch it for you before running it. Oh. So it's now telling me that I don't have that image installed. So that was the, wait, where were we? Up here. So it's saying it's unable to find this image locally. And so instead it will pull this from Docker Hub and then install that. And since hello world doesn't really do anything much, of course, it's instantly there. And it's just giving me a hello message and telling me, okay, you've installed Docker correctly. Everything's working, which is all that the hello world example was meant to do. So let's try a slightly more difficult example, let's say. So we could do Docker run. We can also add things to that. So in particular, we can make this interactive. So the I stands for interactive and the T stands for terminal. So that means that I'll get an interactive terminal into the Docker container that I'm starting now. And instead of using this hello world image, what I'm going to do is I'm going to start Ubuntu. And this by default will pull the latest Ubuntu version. But of course, you can give the version number if you're interested in a particular version of Ubuntu. And this one I've already got installed because it would have taken a while to do otherwise. So I made sure that image was there. And so we're now instantly in the terminal. If you've never run Docker before on your machine, then that's not going to happen. What's actually going to happen is that you will have to wait a while it downloads the entire image for you. But now we're in here and we just have a normal command line interface on Ubuntu like we would if this was running locally. And so now I can, for example, install some packages. So I do update. And then I can install, for example, just a very simple thing. So this is just installing Figlet. And now I can use that and again, just type out hello world essentially. And So all Figlet does is it produces these little ASCII pieces to demonstrate that that worked. Okay. So normally what we don't want to do is don't want to do this interactively, because once I've exited that Docker container, everything that I've done has gotten lost. So what we want to do is we want to write a Docker file which stores what we've done. So I've produced a Docker file which just contains the same things that I've just done locally. We start by saying which base image we want to use. In this case, I'm using a Ubuntu base image. And then I again apt-get update, apt-get install Figlet, and then run that. So there's a slight difference from a bash script. So if you're used to writing bash scripts, you'll probably think this looks really familiar. It looks essentially like a bash script, and it's essentially written like one. The only difference is that at the start of each line, you tell the Docker file what kind of a thing you want to do. So for example, from tells us what the base image should be, and run obviously runs this. The difference to command, so CMD, is that run will do this when you're building the image, and the command will do this when you're starting the image. So what this will do is it will, when building, update and install Figlet, and when you're running, it will print hello world. So let me demonstrate that. So now we can Docker build from this Docker file. We can give our new Docker image a name. So in this case, I will just call it hello world. And then we tell it where the Docker file is. In this case, it's exactly in the directory that I'm currently in. If I was in a different directory, I could give it a path instead. And so now it's doing everything that's listed under run, which is apt-get update and apt-get install. And now it's finished. So now that I've got that, I can also run the same image. So I can run. And now I have to tell it which one I want to run. So that's hello world, which is what I've named it. And here it goes. And now it has run the command, which is under command. If I want to do the same thing in an Umbrage context, then I can do that. So I could take exactly this image and I could try to turn this into a Docker image. It really makes no sense to be printing out text in an Umbrage context, but just to show you how it works, this is what the Docker file would look like if we wanted to use it for that. So the first thing that changes is we also need to have an Umbrage server inside our Docker container. So we take the test server.py, which is in our current directory, and we also copy that into the Docker file. Then we need a copy of Umbrage. So I need to install pip, and then I can pip install Umbrage. So this is all the installation I'm doing. And then finally, instead of running the Figlet command, I run the Umbrage server as a command at the end. And that's all the changes I need. And we can have a brief look at the Umbrage server, which is the bit that you need to write for your model if you want to write an Umbrage model. So this is a simple test model, and it's called test server. It has input sizes and output sizes that I have to define. So this is the input, the size of the input parameter vector, and the output. And in this case, in some sense, these could just both not exist. And then finally, I'll call my code. So normally here you'd be calling your Python library, because this is a Python server. In this case, just to show something really simple, I'm just making a system call and just calling Figlet to print something and printing the output parameter. And that's it. So then I could build this container exactly the same way I built the previous one, and I could run it and serve it essentially. So quickly do that. Okay, so we can now see that this is already taking a little bit longer, but it shouldn't take too long, hopefully. Okay, so now it's done with all the previous dependencies and it's installing Umbrage. Now it's installed Umbrage and it's done. And now we can run that. And the difference in this Docker command now is that I'm giving it a port as well. So with the Umbrage server, they're being served somewhere. So I have to tell it what port to do that on. And just randomly, I've given it 4242. And that means that when I want to talk to the server later, I have to remember what port I put it on. And I've named the image Umbrage Hello World before because it's really not running anything. Okay, so now that is running, and we've seen that multiple times already now. So hopefully that's starting to become familiar. And now we can just give it a command and send some requests to our new server. So I've done that, I've sent that off, and now it's, again, printed hello world as it did before, but now using Umbrage. Just the only difference. Okay. So I've put all of this on the slides if you want to look back on it, but I'm obviously going to skip through these now. The two basic Docker command line interface commands that I didn't show you now that are quite useful in this context are docker image ls, which tells you all the current images you've got, and docker image rm, which will remove them. So the issue if you're running this for a long time is that at some point the images you've got pile up and they get quite expensive. So in particular, the tsunami example is one you probably want to delete again when you're done with it, because it comes with quite a large amount of data, and that data then just takes up space on your system. So when I first started using Docker, I never deleted these, and at some point I ran completely out of space on my computer. I was like, how has this happened? I didn't even save a lot of stuff, and then realized that I had like many gigabytes of Docker images lying around. So in that context, it might be important to remember to do this every now and then. Okay, so we've covered some of the more commonly used Docker commands. There's others that you can find in the Docker documentation if you're interested. But the important ones are from, which sets your base image. So now we've used Ubuntu. If you want to use MPI across containers, multi-nodes, then there's also an MPI base image, which is called MPI operator that you can use, which allows you to do that. Run executes Linux commands while building, and command executes them while running. So the only difference between those two is when that happens. You can also set the current working directory in order to change directory in a way that stays. You can set environment variables using env. And the one that we've also already used is copy, which copies data into the image. So you can use that to copy the test server in, but you can also use it to copy other data in that you might need inside your image. So with this, you should be able to create your own Docker file. And that's exactly what we're going to do in the tutorial session after this. The basic workflow is really simple. You create a container image with your application. Then you create a corresponding Umbrage server file and also place that in the Docker container as we've done in the example. And then you can essentially run the container. Always remember to specify the ports. And then you can request model evaluations as we did. You can do this either the way that I did it, which was via a simple curl command, or probably the way that you want to do it in the end, as Linus has showed you with an Umbridge client, which is a slightly better way of doing it. Okay, and then if you ever need to tweak the model, you can update the Docker file and rebuild. Okay, so very briefly, I'll skip through this essentially because it's also in the tutorial. But these are the basic commands that you might want to use when you're writing the client side of things. So getting input sizes and output sizes, evaluating the model itself now just becomes a call to the model, and passing configuration options Linus has also already shown. And if you want to make your own model class, then I'd recommend that you just start from the minimal example. So there's a minimal server that you can copy, and then you can modify that based on what you have. And again, you just serve it the normal way that we've shown now multiple times. Okay. Okay, so now I want to switch gears a little bit and talk just very briefly about the models and benchmarks. So once we had Umbridge working, we realized that one of the advantages of this approach is that you can have very reproducible results. And that means that you can provide benchmark problems in a way that wasn't previously possible, perhaps. So normally when people specify benchmark problems, they try to choose something very simple so that they can fully specify it and so that it can be re-implemented in multiple different packages. And then different people can try the same problem and see how different methods perform on it in order to, for example, compare UQ methods. In UQ, there seems to be very few benchmark problems which get used in a community-wide setting. And I think part of the problem there is that specifying these fully is actually rather complicated. And in particular, you don't want to always be running the same kind of Laplace problem as your forward model. You maybe want to do something more complex, but in that case, nobody is willing to invest the time into implementing this in all sorts of packages. And so with the containerization, we can now very easily make these models and benchmarks available to people, and everyone can try them with their own method. Some of the other examples of this, advantages of this are that we have some automated testing, so we can just build and test things via GitHub Actions. We've also got partially automated documentation, so it will produce documentation for you that documents, for example, input and output sizes automatically, and the only bits that you have to write are the explanation of what your model actually does, which can't be inferred purely from the code. And yeah, the ease of use I now have talked about quite extensively, I think. So you can access them through any language, you can access them through a simple function call in Umbridge, rather than needing to install anything or working out how to call them. Okay. So the first bit of the library concerns the models. An Umbridge model is essentially just a function which maps a vector onto a vector, and it can support any of the following evaluation gradients, Jacobians or Hessians. And a forward model could be used in multiple benchmarks. So inherently, they're not a benchmark yet. They need to come with some specification of the UQ problem that you want to solve. So you could, in theory, have one model which has a corresponding inference problem and the corresponding propagation problem, which are both in the benchmark library. We've got a fair amount of models at this point, some of which various people have spoken throughout today about. There's a very basic Euler-Bernoulli beam. L2C is actually a Fortran model which estimates resistance. There's a tsunami model that Linus has talked about extensively, which is written in Exahype. There's also a composite material, which computes a simple elastic deformation of a composite part. there's a tritium diffusion example. There's the agent-based disease transmission model, which Catherine talked about in detail. And then, since we always need to have at least one Laplacian somewhere, there's a membrane model in there as well, which is actually a very well-specified benchmark. Okay. Which leads me into the benchmarks themselves. So from an Umbridge side, an uncertainty quantification benchmark is identical to models, and they only differ in that they fully define a UQ problem rather than just defining a forward model. And they're based on the forward models that I talked about previously. So there's inference benchmarks, which basically define a Bayesian posterior density, and your goal is to determine the posterior distribution or quantities derived from it. There are propagation benchmarks in which you put in an input distribution probability and then find the corresponding distribution of the output, or again, a quantity derived thereof. And then we've got optimization benchmarks, which define optimization problems rather than uncertainty quantification problems. But since they follow exactly the same basic premise that your model can be seen as something where you need to be able to evaluate or potentially evaluate gradients or Hessians of, it actually works quite well also for optimization. So we have various inference benchmarks. In fact, we have quite a few inference benchmarks that have accumulated over time. The other one that you've seen already is the analytic densities one, which Sergey and Linus have both shown briefly. But there's a wide range of other ones, so I'd encourage you just to have a look through those. I'm not going to talk about each and every single one of them now. But suffice it to say that there's quite a few of them that you can look at. Then there's propagation benchmarks. So we have fewer propagation benchmarks than we have inference benchmarks. And we have even fewer optimization benchmarks. And you'll note that the L2C example actually has shown up in all three categories. So this is actually a forward model for which we have an optimization, an inference, and a propagation benchmark. And this benchmark library is not intended to be in any sense a static resource. So the status quo, as I've just shown it, is not meant to remain like that, but rather we would like it to be a community project, and we welcome all contributions to it, essentially. So the one thing to note in that context is that we don't want it to become completely bloated. So we want models or benchmarks which have features that are not found yet in existing benchmarks. But if you have such a model or a benchmark, then we are more than happy to add it. And we're also happy to kind of help you to get that in there if that's something that you want to do. But essentially all you have to do is you need to implement the model and the benchmark, and then make a pull request on the repository, and we'll just add it in. In this context, I guess I should tell you what you need to have in order to have finished a model or a benchmark. So you need a Docker file or a container which contains the Umbridge server and your application itself. It needs to have a README, and the README needs to follow the predefined structure that we've put in place. So there is a script that auto-generates this file. So that's the partially automated documentation aspect. So you only really need to fill in the description of your model and potentially point people towards any publications that they need to fully understand it. So normally these are descriptions that are along the lines of maybe 2 to 3 paragraphs. There certainly shouldn't be much longer than that. And then probably you want, if you're adding in a model, you'd want the corresponding benchmark, which uses this forward model. And that might require some additional files, some additional input data, or various other things. Okay, so I said questions. I'm going to stop screen sharing in a second, but I wanted to talk briefly about the tutorial, which is what you started with. So you went through, hopefully, in the first session, steps 1 to 3 of the tutorial, and it's now time to look at 4 to 5. So the tutorial will go through again some of the things that I spoke about, and then leads into you producing your own Umbridge model. So you can go directly to section 5 and create your own model server, or you can start in section 4 and first look at Umbridge servers more generally. If you have an application that you want to wrap in a container and that hasn't been wrapped yet, then this is a great opportunity to do this, and we're really happy to help you with that in this section. So please don't hesitate to ask us for help with that. But if you don't have an application, then you can just use the minimal server you created in the earlier session.